first question that comes to our mind is, what is quadrature? So quadrature is the process where you can find the area of some bounded region of that curve. So this you might have studied in your school as well, how to find the area bounded by curves. So this is the same as that topic. So firstly, what we'll see, we'll find the area under a continuous curve in x-axis. That means if some curve is given in this form, so and we are asked find the area between the points 1 and 4. So what we do, we draw this line, dotted line, and whatever is this area under this curve from this x-axis, that we will calculate through the process of integration. So what is the process to calculate this area? If y is equal to fx is some curve that is defined on this interval, closed interval a to b, then its area is calculated between the ordinates. So we are interested to calculate it from the point A and the point B. So between these points, what is the area of that given curve? That is calculated by taking it as single integral. So whatever is the value of y, substitute here and take the limits from A to B. Simple as that. So now the question is, find the area which is bounded by the line y is equal to x, x is equal to -1 and x is equal to 1. So can you do that? I assume you can do that. So for that, firstly you would have to visualize this particular region. So what is this region? Firstly we'll draw these lines. These are simple straight lines. This is x-axis, this is y-axis. The line y is equal to x. It would be a line which has an angle of 45 degree with this x-axis. So this is a line y is equal to x. What is the line? X is equal to 1. Say this is the point 1. So x is equal to 1 would be this line. A line, straight vertical line passing through x is equal to 1. And another line at this point, x is equal to -1 would be another vertical line which will pass through the point x is equal to -1. So what would be the region bounded by all these three curves? So it would be this region. This is the line, right? And this is one line. So what is the region in between them? This is this region. And what is the region between this line and this line? So it is this region. So we are to calculate the area of this particular region. So how can you do that? Now you see this region that is attached to this x-axis, that is bounded by this x-axis. So how can we find this area? This area would be equal to, let us name it, this is the point O, this is the point A, this is the point B, this is the point C, say, this is the point D. So the total area that we are to calculate is this area OCD plus OAB, right? But because they are symmetrical with each other, so we can write this to be twice the area of OAB. So what would be this area? How can you calculate this area? You know what is the limit of x? You know what is y? So the formula is integration, 2 will come as such, integration from the limits of x, y into dx. So it would be the limits of this quantity x. What is the value of y given to you? This curve has equation y is equal to x. So we have to integration to the values of y here. Y is given to be x dx.
Ma'am, I was.
So here, what we'll do, we have substituted the value of y. So here, what we will do, we will substitute the value of y, that is equal to x, and we will take the limits of this x. Now see in this region, this is a region. What is the variation of x that is occurring? Here the value of x is 0, here the value of x is 1. So the limits of x will vary from 0 to 1, right? So it would be from 0 to 1. So this is the simple integration. So its integration would be x square by 2. So it is equal to 2 into 1 by 2. So the answer is 1 unit. The area of this particular region, that is equal to this both shaded region, that is equal to 1 unit, right? So the next is how to find the area, of the given curve and the y-axis, the region which is bounded by the curve and the y-axis. So its area, that is simply calculated by taking the value of x here, and we'll take the limits of y. These are the limits of y. Say y varies from point C to the point D, right? So if you have some area of this kind, suppose this is our coordinate axis and this is some curve given to you, and this point is say D, this point is say C. So you will make a horizontal line from this point C and from this point D to this curve. So whatever is this region, we are to calculate its area. So its area is calculated by taking a horizontal strip. So what you will do here, you will draw a horizontal strip of this kind, very small horizontal strip. So now what is the equation for this? Here what is varying? Here y is varying, right? In moving from here to here, what is varying? X is varying. So we will substitute x here, and when you move this strip from here to here, so that means in that case what is varying? Y is varying. Y varies from C to D. So overall our limits are with respect to y, and they are varying from C to D. So that is what we are doing when we are calculating the area between the given curve and y-axis. For x-axis case, what we were doing, suppose our curve was of this kind and this was some point A and this was some point B. So what we were doing, we were calculating this area. This area was calculated when you take the vertical strip. For taking this vertical strip, what we are doing, our y is varying. Our maximum value of y is this one, minimum value of y is this one. So your integration was performed for, say this curve was y is equal to f of x. So integration was performed when you take y, and here y value is 0. So the maximum value of y was y, whatever is given to you, minus the value of 0, and then we have performed this thing, we will take its integration. So what we are doing, we are creating numerous vertical strips and we are summing all this. So when you sum all this, you will get the complete area for this region. So we will sum all this strip. So summing all this strips means we are moving from here to here. So that means we are integrating with respect to x and from the limits a to b. So this was the formula when you were calculating it using the vertical strips. When you are calculating it using the horizontal strip, it is this one. So let us see one example for this. So question is, calculate the area bounded by the curve y square minus 4y plus 2x is equal to 0 and y-axis. So in order to calculate the area, firstly you would have to visualize what is the region given to you. So for that we will just try to make the square of this term y. We will try to complete the square of this term y. So our term is y square minus 4y plus 2x, that is equal to 0. For completing the square, what you will do, you will divide by the coefficient of y by 2. So we will have 2, and then we will square this term. So we would have y square minus 4y, and then we would have plus 4 on this side and plus 4 on this side as well, right? And this is plus 2x as such. So now this thing becomes the whole square of y minus 2 whole square, this whole quantity, and 2x as such, and this is 4, right? So you could write this curve to be y minus 2 whole square. This is equal to minus 2 into, you can shift this term to the right hand side, so you would have 4 minus 2x. So this is the curve that you obtain. Now this is the equation of parabola. So, and moreover, what kind of parabola this is? This is the left-handed parabola. The vertex for this is, you can write this to be minus 2x minus 2. So your curve is y minus 2 whole square, that is equal to minus 2x minus 2, right? So this would have vertex at the point 2, 2. So the equation or the graph for this curve would something be like this. This is x-axis, this is y-axis. So now you have to see at which points this crosses the y-axis. So for that, what we do? At what points?
Excuse me, ma'am.
So we were seeing at which points the curve meets y-axis. For the curve to meet y-axis, we will substitute x is equal to 0. So, substitute x is equal to 0. What are the values of y? So here, we will substitute x is equal to 0 in the given curve. We would have y minus 2 whole square, that is minus 2, 0 minus 2. So this is equal to, or we can simply do this in the given curve. The given curve was y square minus 4y plus 2x is equal to 0. So here when you substitute x is equal to 0, you would have y square minus 4y is equal to 0, or you get y is equal to 0 and y is equal to 4. So these 2 points we have with us. So one point is 0, 0, another point is 0, 4. So first point is this one, origin 0, 0, another point is 0, 4. So the curve meets this y-axis at these 2 points, and moreover this is a parabola situated whose vertex is situated at this point. This point is 2, 2. So your the graph would something be like this, right? So this would be the parabola, and we are to calculate this particular area. So how can we calculate this area? To calculate this area, we would simply write the value of x here, x into dy. So what is x given here from this equation? This was our equation. So the value of x, that is equal to 4y minus y square divided by 2. This is the value of x. So we'll substitute the same value of x, and your limit will now vary from y, because we are taking integration with respect to y. So your y varies from 0 to the point 4. So this is the point 0, this is the point 4. So integration from 0 to 4, the value of x is 4y minus y square divided by 2 into dy. So now we just have to perform the integration with respect to y. So this would be 2y, and the integration of 2y is 2y square by 2. 2y square by 2. And then the integration of y 1 by 2 as such, the integration of y square is y cube by 3, and the limits varies from 0 to 4. So you can solve this one. So what answer will you get from here? When you simplify this, when you substitute all the limits, you will have 16 by 3 as the answer. So this is the area of this shaded region. So I hope this is clear. The next is, you are to calculate the area bounded by two curves. So for that, suppose the first curve is given to be y is equal to f of x, and another curve is given to be y is equal to g of x. These are two functions which are defined on this interval a to b, and we at all points have this g of x less than equal to f of x, right? So that means if we have some curve this one and we have some curve this one, so this curve is your f of x and this curve is your g of x, and because we are saying f of x is greater at all points than g of x, therefore our curves are of this kind. Suppose this is the point A, this is the point B, so between these points the area which is bounded by these two curves is represented by this shaded region. So what would be the area in this case? The area would be calculated from this limits from A to B. So again, now here you have a choice. You can either make this vertical strip or you can make this horizontal strip. If you make the vertical strip, the variation of y you will note that variation. So it would be the upper value of y. What is the value of y here? It is f of x. And what is the value of y here? It is g of x. So f of x minus g of x, and this variation is happening with respect to y, so you will substitute the value of y here, and then we will take such strips from here to here. So we will draw many strips from here to here to cover this whole region. So that means we will move from A to B from here. So our limits of integration are x varies from A to B. So this is the general formula. So let us see one simple question. The question is, find the area of the region. Find the area of the region bounded by the line y is equal to x and the line y is equal to x square. So this is the question that you are to answer. So firstly, we will visualize the given region. So this is our y-axis and this is our x-axis, and then we can draw this line y is equal to x. It would be this line, right? Y is equal to x, and what is this? Y is equal to x square. This is the upper parabola having vertex at origin. So this is the origin 0, 0 point. So what is the area that is bounded by these two curves? This is this area. So we know this point, both of these line passes through origin. So one point is 0, 0. Another point is this one, and you don't know what are the coordinates. So what you do, you will find the intersection for these two curves. So one curve is y is equal to x square, another curve is y is equal to x. So when you substitute the value of x here, so you would have y is equal to y square, or y square minus y is equal to 0, or y into y minus 1 is equal to 0. So you have the other point as y is equal to 0 and 1. So the other point, this one is having the value as 1, because y is equal to x, so the value of x is also 1 here. So this point is 1, 1. So now let us see what is the area for this curve. The area here is equal to the integration. Now what is the limits for this integration? It will have the limits of x. So, and in between, what do I write? I will write the equation for this curve, the value of y for this curve, that is equal to, for this curve we have y is equal to x. So the value of y here is x, and for this curve, what is the equation for this curve? It has equation y is equal to x square. So the value of y here is x square, and the limits here varies from, the limit here varies from the point 0 to 1, because we are moving from 0 to the point 1. That means we will make this vertical strip. Whatever is the value of y, we'll substitute here. Whatever is the value of y here, we'll substitute here, and we'll take the limits of x from 0 to this end point 1. So 0 to 1. So now you can quickly perform this integration. So 0 to 1, it would be x square by 2 minus x cube by 3, and the limits varies from 0 to 1. So the final answer is, it is 1 by 2 minus 1 by 3, which is equal to 1 by 6. So this is the final answer. So I hope these kind of questions you can do very easily. These are very simple.